Finding equations of linear models. In this example, the number of Americans who have a passport has increased approximately linearly from 11.1 million in 1990 to 109.8 million in 2011. Source: U.S. State Department. Let n be the number in millions of Americans who have a passport at t years since 1990. Find an equation of a linear model to describe the data. So our first step is to figure out what our independent and dependent variables are. N is the number in millions of Americans who have a passport at t years since 1990. How many people have a passport depends on what year it is. So our order pair is t, n, where t, years, is the independent variable and the number in millions is the dependent variable. Now we want to look at the statement 11.1 million in 1990. Since t is t years since 1990, we're starting with 11.1 million. 1990 is year 0. Our first order pair is 0, 11.1. 0 represents 1990 and 11.1 million had passports. Looking at our second statement, 109.8 million in 2011, to decide that order pair, we need to figure out how many years has passed from 1990 to 2011. So 2011 minus 1990 gives us 21. So our second order pair is 21, 109.8. In order to find an equation for the line, we either need the slope and the y-intercept, the slope and a point, or 2 points. Here we have 2 points. Using our slope formula, we can find the slope of our line. Our slope formula is the change in y over the change in x. So m equals 109.8 minus 11.1 divided by 21 minus 0. To calculate this, we want to start with open parenthesis 109.8 minus 11.1 close parenthesis. We need it to subtract before it divides. Divide, and again we need to subtract first, so open parenthesis 21 minus 0 close parenthesis, and we get 4.7. So m equals 4.7. Also, we have the order pair 0, 11.1, which means my y-intercept is 11.1. Using our slope-intercept form, we can write the equation of our line. Now we can find the equation of the line. My y value is n, my m is 4.7, my x value is t, plus b, my y-intercept, 11.1. The equation of the linear model to describe our data is n equals 4.7t plus 11.1. Finding an equation of a linear model by using data displayed in a table. To find an equation of a linear model given some data, 1. Create a scattergram of the data. 2. Determine whether there is a line that comes close to the data points. If so, choose 2 points, not necessarily data points, you can use to find the equation of a linear model. 3. Find an equation of the line you identified in step 2. 4. Use a graphing calculator to verify the graph of your equation comes close to the points of the scattergram. In this example, Table 30 shows for various years the percentage of Americans who are baseball fans. Let P be the percentage of Americans who are baseball fans at T years since 1990. Use a graphing calculator to draw a scattergram of the data. So for our table, the percentages of Americans who are baseball fans, in the year 1999, there's 54%. 2001, 51. 2003, 50. 2005, 48. 2007, 44. 2008, 43. In order to graph a scattergram of the data, we need to find T and P. T represents the years since 1990. So for 1999, T is 9. For 2001, T is 11. For 2003, T is 13. For 2005, T is 15. For 2007, T is 17. And for 2008, T is 18. Percent we can just use as P. On our graphing calculator, we want to go to Stat, 1 Edit, make sure we're under L1, and that's where we're going to type our values for T. 9, 11, 13, 15, 17, 18. Pressing Enter after every number. Moving over to L2, we're ready to type in our percentages. 54, 51, 50, 48, 44, 43. Now that we have our data, we're ready to make our scattergram. Second, y equals takes you to your stat plot. Our first stat plot is on. I have my scatter plot selected. I have my X list is L1, my Y list is L2. Zoom, 9 for zoom stat, and then I have a graph of my data. My data does look like it is approximately linearly related. I need to choose 2 points to create my line. I need 2 points to find the slope, and then I can use one of those points in the slope to find my y-intercept. With the slope and y-intercept, I can create an equation of my line. Looking at my data points, a good approximation of my line would be to use the first point and the last point. You want to make sure your line is in the middle of the data, and if it can cross a couple of points, that's an added bonus. Push trace. My first point is 954. I press the right arrow button. And my last point is 1843. So those are the 2 points I want to use to find the equation of my line. So the first thing I need to do is find my slope. M equals the change in y over the change in x. Then once I have my slope, I can use the slope-intercept form of the line to find b, then use the slope y-intercept to find the equation of my line. So using the points 954 and 1843, first I'm going to find my slope. 43 minus 54 over 18 minus 9. 43 minus 54 is negative 11. 18 minus 9 is 9. So the slope of my line is negative 11 over 9. Now I want to find b. I'm going to use my first point, 954, and my slope to find b. Y is 54 equals my slope, negative 11 over 9, times x, which is 9, plus b. 54 equals negative 11 over 9 times 9 is negative 11 plus b. Add 11 to both sides. 65 equals b. Now we're ready to write the equation of our line. Our year is t and our percent is p. So p equals negative 11 over 9 t plus 65. Draw the line and the scattergram in the same viewing window. Verify that the line passes through the 2 points chosen in finding the equation and that it comes close to all the data points. On our calculator, we want to graph our line. Press y equals. Type in our line at y1, negative 11 divided by 9, x plus 65. Press graph. Our line does go through the first point and the last point, and it appears to be the line of best fit for our data. Finding equations of linear models. We can construct a line from two data points. Finding the equation of a linear model by using data displayed in a table. Graph your data from the table. Make sure it's approximately linear related. Choose 2 points that would help us get our line of best fit. Use those 2 points to find the slope using y equals mx plus b and one of the points, and the slope, find b. Then use your slope and y-intercept to write the equation of your line using the variables for the data.